Hello guys, today we'll be talking about equations of motion. Equations of motions are mathematical formulae that describe the relationship between an object's position, velocity and acceleration as it moves over time. These equations are basic to understanding and predicting the motion of objects in physics. So the three equations of motions are where each variable has its significance. And so we're going to dive into the derivation of each of the equations of motion, beginning with equation 1. From the definition of acceleration, we know that acceleration equals the ratio of change in velocity to time taken. And by variables, you have a equals v minus u over t, where v is the final velocity, u is the initial velocity, and then t is the time taken. And by cross multiplying, you have v minus u equals to at. Adding u to both sides gives us v equals u plus at, and that is the first equation of motion. Alright, each of them have their dimensional units. For velocity, you have the meter per second. Acceleration, you have meter per second square, and time taken is measured in seconds. Move over to derivation of equation 2. For a body starting with an initial speed u and accelerating uniformly and covering a distance s in time t to reach a final speed v, we have average speed equals total distance over time taken. Average speed will be initial speed plus final speed divided by 2 equals to distance over time, using their variables. And then doing the mathematical manipulations, we're left with this. So substituting for v equals u plus at into equation 2, that is, remember v equals u plus at is the first equation of motion. So when you substitute into this formula, replacing v with v equals u plus at, we have distance or position, as the case may be, equals u plus at over 2, all multiplied by t. And when you evaluate, you are left with this. And therefore s is equal to ut plus at squared over 2. This is by expansion. Okay, when you expand this, you have, when you factorize this out, you have this. That's what you have there. Talking about the derivation of the third equation of motion. Okay, from equation 1, where you have final velocity equals initial velocity plus acceleration times time, squaring both sides of the equation, we have v squared equals u plus at all squared. Now on the right hand side, we'll be dealing with what we call expansion here. Expansion. So when you expand the right hand side, this is what you have. Okay, all right, carrying out the mathematical evaluation, you see on this side you factorize 2a, that gives us this. When you factor out 2a, you have this. And if you recall, going back to our second equation of motion, where we have ut x equals ut plus at squared over 2. So we replace this quantity in brackets, we replace it with s, and there you have v square equals u square plus 2as, where s is ut plus at square over 2. All right, so that's for the equations of motion. Now there are things you need to know when applying these equations of motion in solving problems. First thing you take note of is to substitute the given values and solve for the unknown variables. You identify the values given in the question, and then you substitute them into any of the equations you think can give an answer to the question, and then you solve for the unknown. And secondly, you use the appropriate equation of motion for the type of motion. And thirdly, pay attention to units and dimensions. Okay, units are very, very important in physics, so we don't joke with them. All right, now talking about equations of motion, do they have real world application? Oh yes. Now in real world application, you can use it to calculate the position and velocity of a car over time. You can also predict time, okay, and all of that. And then let's take a look at practice problem. I think 2 examples are here for us to study and see how we can do it on our own. Okay, the first example is this: a car travels from rest to a velocity of 50 meters per second in 10 seconds. Find its acceleration. Now looking at this question, you will notice that 50 meters per second starts for the final velocity. Remember, the car travels from rest, so it means that the initial velocity in this question is 0 because it travels from rest. It started from rest and then it traveled up to 50 meters per second, which is the final velocity. And in what time duration? In 10 seconds. So you're asked to find its acceleration. So looking at what has been given, okay, you now substitute. The u here represents initial velocity, which is 0 meter per second, and v is the final velocity, which is 50 meter per second, as well as time t, 10 seconds, and you have to find a. So we apply the definition, the mathematical definition for linear acceleration, which says that a equals v minus u over t. Substituting the given values in this equation, you have 50 minus 0 over 10, and that gives us 50 over 10, and that leaves us with 5 meters per second square. Okay, over to the next example. A ball is thrown from the ground with an initial velocity of 20 meters per second. Find its position and velocity after 5 seconds. Take a equals 10 meters per second square. Okay, in this question we are given initial velocity of 20 meters per second and then a time of 5 seconds. So we are asked to find two things: the position of the ball as well as its velocity after 5 seconds. Okay, and there you go. Using position. Okay, yeah, that gives us position. This is the position of the object, and this is the velocity, final velocity of the object. That's you're using the third equation of motion for velocity. V square equals u square plus 2as, and there you go.